All right, let's jump right into this explainer. Today, we're taking one of the absolute most famously overpowered abilities in all of modern pop culture, and we are putting it under a rigorous, real-world microscope. We're asking what seems like a pretty straightforward question. Can the ultimate anime superpower actually survive the strict, totally unforgiving rules of real-world mathematics? Well, get ready because we're going to push the boundaries of calculus, measure theory, and even the curvature of space itself to find out. And the reason this is just so incredibly exciting is because if real advanced mathematics can prove an anime magic trick is physically viable, man, it completely changes how we look at physics in fiction.
To really ground this explainer, let's look at the massive hit anime and manga Jujutsu Kaisen. The character Gojo Satoru possesses a defensive technique that he just calls infinity, and the concept is actually incredibly elegant. Basically, between Gojo and any attacker, there's a distance, right? Well, Gojo's ability forces that distance to be halved, and then halved again, and then halved again, infinitely. So no matter how fast a fist or a weapon is flying at him, it always has to cross half the remaining distance before it can actually land a hit. Because of this, an infinite sequence of steps is created, the attack basically slows to a complete crawl asymptotically, and Gojo is literally never touched. Sounds flawless, right?
But here's the really fascinating twist. This modern anime trope, it isn't actually new at all. It's a 2,500-year-old philosophical trap. Way back around 450 BCE, a Greek philosopher named Zeno of Elea proposed an identical logic puzzle, and he designed it to prove that all motion is basically just an illusion. He called it the paradox of Achilles and the tortoise. The idea is, Achilles is obviously faster, but if the tortoise gets a head start, Achilles first has to reach where the tortoise started, then half the remaining distance, then half again, on and on. Gojo's infinity and Zeno's paradox have the exact same logical structure, just separated by a couple millennia.
So that brings us to the central mystery we need to solve today. If an attacker, or Achilles for that matter, has to take an infinite number of fractional steps, does that mathematically guarantee they'll never reach their target? Does infinity automatically equal an impenetrable shield? Well, to answer that, we've got to look at what math actually says about infinitely dividing space.
Section 1. The geometric series problem.
Let's move into the debunking phase of our analysis, because while Zeno's logic sounds totally watertight at first, basic calculus actually completely unravels the foundation of Gojo's ultimate defense. If we take our fractional distances, 1/2, then 1/4, then 1/8, 1/16, and so on, and we map them out as geometric areas, a really strange truth emerges. As you can clearly see here, they fit together perfectly. They don't just grow forever. Think about it like this. If you start slicing a cake in half, and then you slice the remaining half, and then slice that remaining half forever, you never magically generate a second cake. The sum of these infinitely many pieces fits flawlessly inside a finite square with an area of exactly 1. It's an infinite number of pieces fitting perfectly into a finite whole.
And we can see this even more clearly mapped out when we look at the actual numbers. When you add up the partial sums of a geometric series where each step is half the previous one, the numbers steadily climb. You go from 0.5 to 0.75 to 0.875 to 0.9375, but they inevitably converge to a finite limit. They approach exactly 1, they never ever exceed it. So what does this all mean for us? It proves that completing an infinite number of steps does not require infinite time or infinite distance. The total time required to cross those infinitely shrinking gaps is itself a completely finite number.
Which leads us directly to this pretty devastating conclusion from our source text. Under the standard rules of geometric series mathematics, infinity offers absolutely no defense whatsoever. As a mathematical barrier against motion, it simply collapses. Achilles easily catches the tortoise, we are perfectly able to cross a room, and an attacker inevitably reaches Gojo Satoru.
Section 2. A barrier of zero size.
But hold on, actually scratch that. We can't stop there. We need to introduce a much deeper layer of mathematical analysis. Because even if the time to cross the barrier is finite, what about the physical footprint of the barrier itself? Like, what about the actual physical points in space where the distance is being halved? To figure out exactly how much physical space Gojo's infinite subdivisions occupy, we have to look to a 20th century tool called the Lebesgue measure. Developed by Henri Lebesgue, this is a mathematical framework that basically helps us assign a literal physical length to incredibly complex, weird subsets of numbers. Imagine trying to measure the total length of a scattered cloud of dust instead of, say, a solid rock. Traditional rulers are going to fail completely there. The Lebesgue measure allows us to mathematically scoop up all those tiny disconnected points and figure out exactly how much real estate they actually consume. And honestly, the mind-bending reality it reveals is absolutely staggering. The subdivision points between Gojo and an attacker, the halfway point, the three-quarter point, the 7/8 point, going on forever, are countably infinite. There is literally a never-ending amount of them. But under the Lebesgue measure, even though there are an infinite number of halfway points, if you were to mathematically shrink-wrap each one of those points to measure their total length, the sum of that length approaches zero. Measured with the full precision of modern mathematics, this infinite set of points takes up absolutely no space. It's what mathematicians call a negligible set, meaning it's an infinite wall with a physical thickness of exactly zero.
Which naturally brings us to the most obvious, glaring question of this entire explainer. If measure theory strictly proves that his shield has a physical thickness of absolute zero, and calculus definitively proves that it takes a totally finite amount of time to cross it, how in the world does he remain untouchable? Why does every single attack still slow to a dead halt?
Section 3. The Riemannian Geometry Twist.
All right, here is the massive plot twist. To save this beloved superpower, we basically have to throw out flat mathematics entirely. And we've got to dive into the advanced geometry that the anime's creator intentionally used to justify it. In a 2021 collaboration published in Jump Giga, the creator of Jujutsu Kaisen worked directly with real-world researchers and mathematicians from the Riken Institute to formalize the precise scientific mechanism behind infinity. And they concluded something incredible. Gojo isn't just dividing a flat distance between 2 points. No, he is literally manipulating and curving the fabric of space itself around his body.
To really understand this, we have to contrast two concepts of space. So normally, we live in what's called Euclidean space. It's normal, it's flat, and taking one physical step forward equals exactly one felt step. Simple enough, but Gojo transforms his immediate vicinity into a Riemannian manifold. In a Riemannian manifold, you introduce an incredibly powerful mathematical concept called a metric tensor. Basically, this means the very fabric of space dictates how distance is physically experienced, and that experience can completely change depending on exactly where you are standing. A really great real-world equivalent is looking at a flat 2D map of the Earth. On the flat map, Greenland looks absolutely massive, right? Almost the size of Africa? But because the Earth is actually a curved sphere, the metric of that map is highly distorted at the poles. The distance just isn't what it appears to be.
So, the Riken mathematicians propose that Gojo's metric tensor uses what is called a Gaussian kernel. Now, in machine learning, a Gaussian kernel is often used to measure how close complex data points are to each other in abstract data spaces. It basically defines similarity. But by applying this to actual physical space, it suddenly measures how dense reality is at any given coordinate. The geometry around Gojo becomes highly nonlinear. Essentially, the core density of the ruler changes drastically based on your precise location.
Think of it like holding a physical ruler that magically changes its own markings depending on who's holding it. Step 1. Far away from Gojo, the metric is totally flat. If an attacker takes a physical step of 0.1 meters, it feels like 0.1 meters, completely normal Euclidean space. But step 2, the attacker gets closer, they enter Gojo's active space, and the metric tensor mathematically blows up. It just spikes exponentially. So then step 3, right near Gojo, the attacker takes that exact same physical step of 0.1 meters, but the highly curved geometry of space forces them to experience it as feeling infinitely long. The universe literally stretches their physical step right before they can land a hit.
So, the absolutely crucial takeaway here is that both realities are simultaneously true, entirely depending on the exact mathematical framework you apply. The barrier has an absolute zero length on a flat, standard Euclidean ruler, but Gojo's curved Riemannian geometry acts as a fundamentally different ruler, amplifying those exact same negligible points into an impenetrable, infinitely stretching wall. The math actually holds up. The impossible becomes entirely possible, provided you allow for the localized curving of the universe.
Which leaves us with this final, thrilling thought to close out our explainer today. If a pop culture magic trick, like a literally unbeatable anime superpower, can be perfectly validated by applying advanced machine learning formulas and Riemannian geometry, what other seemingly impossible fictions are out there, just waiting for the right kind of math to prove them entirely real? Keep questioning the impossible, everyone.